Hi there everyone, welcome back to Cody's Lab. So in another project, the video which probably won't be posted till early next month, I acquired a bunch of sand that had a little bit of fine gold powder in it. You can see here I've panned it out using a gold pan. Gold is usually very easy to separate from sand because gold's high density makes it so that it sinks down to the very bottom. You can actually kind of see that here, how it's kind of separated in a gradient. But also water, as you kind of wash it against the gold. The gold's high density means that it has a high mass to surface area ratio. But the problem here is that the cube law is making it so that the mass ratio is actually not that significant. You know, a little bit of flowing water actually can move this gold around quite easily. You know, relatively easily. In fact, this is about as concentrated as I could make it before the gold starts washing over the lip of the pan. Normally the sand will protect the gold from that happening, but once there's not enough sand to do that, then the gold kind of mixes with the sand and it flows right over the top. Also, I don't know if you can see it, if I rock the pan back like this, and let it dry out for a second and then push it back, you can see some of the gold actually floats on the water. You see that right there? That's surface tension doing that. Despite the fact that gold is nearly 20 times denser than water, you're actually watching it float because the size of the particles are just too small to punch through the surface tension. I can break that up by adding a little bit of soap. You can see the particles swim around, and also by giving it a little bit of agitation to push the gold down below. But that really is a problem. If I were to try to continue panning at this, I would just lose more and more gold. And you can see even over here where the gold looks like it's pretty pure already, if I kind of agitate it a little bit, you can see that it is trapping quite a lot of sand. Normally, given this situation, I would either put a drop of mercury in there to collect all the gold, or I would just put the whole mass of it into a furnace along with some flux so I can melt the gold into a single bead. But today I really wanted to try using this. This is Clerici solution, which is made using thallium. Now this is probably worse than using mercury, but I wanted to know if it works. Theoretically it should, because this solution weighs about 4 grams per cubic centimeter, and the sand down there weighs about 3. And gold, of course, which is much heavier than 4, will sink. So let me dry off all this water here and transfer it into a test tube. We'll see what happens when I combine it with the heavy liquid. Let's see if this will make the sand float. Alright. There's about 2 milliliters worth. Let's get that mixed in there. Oh, I see what's happened. The addition of the sand has caused my solution to crystallize. Should be a simple matter of warming it up to redissolve the crystals. But you can already see that the gold has sunk to the bottom of the test tube. So here we are after warming it up to liquefy the solution. You can see that there is a layer of sand floating on top and a layer of gold on the bottom. Now the gold still has some black specks in it, and that would be my iron oxides. Iron oxide is a bit heavier than the solution, so you can actually see it's kind of separated a little bit though. See the gold's on the you see the gold's underneath the black sand. So now I'll just pull this off with a pipette, and we can wash this with water to remove the thallium. So there it is, everything that was heavier than about 4.5 grams per cubic centimeter. So that does include the black sand, like I mentioned, but fortunately that should be pretty easy to remove. Just use a magnet. There does seem to be a few non-magnetic grains. That's probably hematite or some other heavy mineral. Looks like there might be a few zircon crystals in the mix, but that is pretty much pure gold. And certainly if I melted this down, it would melt down into a bead of gold just fine. It'd still need to be refined, maybe run through acid to get rid of everything else, but there you go. It's mostly pure gold. The Clerici solution is of course completely reusable. I'll just dilute it with water to lower its density so that the sand sinks, just as you can see I've done there. And I'll just wash the remaining solution out of the sand. There, after a few washings I'm left with some clean sand that should have very little thallium left, so this would be safe to dispose of. And of course I have some really dilute Clerici solution that is maybe got a little bit of dirt suspended in it. I will have to filter and evaporate this down before I can use it again, but that's not really a problem. So let's see how much gold I was able to recover. Okay, looks like about 1/10 of a gram. It's not bad. I definitely lost some, but there you go. Hope you enjoyed. I'll see you next time.